Okie dokie. Hello, everyone. Good morning, good afternoon, good evening, wherever you are tuning in from. My name is Niels. I will be taking you through a kind of hands-on workshop for getting hands-on keyboards around MCP, Model Context Protocol. So let me go ahead and present here. Okay. So just quick intro. I'm the Chief ML Engineer at Union.ai. We are the company behind Flyte, which is a very popular machine learning and AI orchestration platform. And today we're going to learn a little bit more about Model Context Protocol, MCP. Last year it was all the rage. This year it's kind of like agents and skills. But I think we're kind of like building the stack on top of each other, right? So as we discover what these kinds of agentic applications need, we'll find the right technologies for solving certain problems. And so just for folks who are coding along, of course, you can just watch me and my screen here. It's always nice, I find, learning stuff with my own two hands. So if you want to code along, I'm assuming you have a GitHub account and you haven't exhausted all of your code spaces credits. I'm not exactly sure how much is given to folks for free. I think it's per month. But if you can turn these code spaces on, yeah, happy for you to follow along with this workshop. So I'm gonna, if you can make your way to the Union.ai workshops repo, thank you, Sage. He just posted it on the chat. This is our repo for the various workshops and tutorials that we run here. And we're just going to scroll down to the MCP section over here. So this is basically the directory containing all the code that we're going to take a look at today. I tried to prepare something kind of fun. So I feel like the weather API MCP server is a little bit commonplace now. So I actually cook a lot. I bake bread every few weeks, and I, do various things in the kitchen. So I wanted to make myself an MCP server that accesses the Spoonacular boot API. There's this service that has a kind of a free tier. Pretty cool. I discovered this as I was preparing for this workshop. There's a free tier, which hopefully I don't fill up on all my quota here. That'd be sad. But if I do, maybe I'll go ahead and pay for it just in this workshop itself. So we're going to need an API key here. You're only going to need an API if you're coding along with me, and if during the local portion. During the when we're serving this on the Flyte cluster itself, the secrets are already there. They're using my own keys, so everyone can look at it. I guess before going into a little bit of a sort of instructional, educational portion on what is MCP and just laying the groundwork there, if you want to code along and you want to deploy this to production on Flyte, a link you should go to is the, if you scroll down a little bit on the prerequisites here, there's a link here that goes to the try v2 cluster that we have here. So try v2 is a place where you can run code. It's a shared cluster, so obviously don't put up anything that's super sensitive or sensitive at all. So this is really just for toy data and just like getting a feel for Flyte. As you can see here, we don't have much going on in this MCP Feb project, but this is where we'll be deploying our MCP server servers to. Okay. Hopefully you should be able to sign in. I'm already signed in, but you should be able to log in through your email, whatever email you used when you were signing up for this workshop. So hopefully, you're already in there, but if it takes a few minutes, yeah, take your time. Okay, so in this workshop, we're going to learn how MCP servers work, their role in the AI agent architecture. We're going to build MCP with tools using the official MCP Python SDK. We will be deploying a local one first, just so you can get a look and feel for how it all works. And then we're going to deploy to production and make sure that it's secure, that it's behind some authentication boundary, so that when if and when you deploy these for real for your own use cases, you have a sense of how to set this up so that it's not like just available to everyone on the internet if you don't want it to. Then we're going to use Claude Code in this workshop as the kind of AI agent client that's going to consume the server that we'll build and deploy. There are other clients out there, so Claude Code would be one of them. Cursor would be another. Any IDE that has kind of like an agent loop functionality inside of it. I'll mostly be focusing on how to configure it with Claude Code, super simple. But I think we'll be using Codespaces, which has like a VS Code editor in there, and I think you could also set it up there if you want. So first, what is MCP? Stands for, as I mentioned earlier, Model Context Protocol. It's an open standard that enables AI assistants to securely connect with external data sources and tools, read and write, right? Mostly read, potentially write, depending on the application. So you can think of this like as REST or REST-like web APIs, but purpose-built for AI consumption. So it's this universal adapter, as you can see in this very simple graph. You have the client over here on the left that consume the MCP servers. They implement the MCP client protocol. We're mostly going to focus on, or we are exclusively going to focus on tools today. Resources are, the MCP protocol has a lot in it, but from my experience, tools implement like the most useful thing about them, in my opinion. Then you have the MCP server here that we will see how to build today. And those are kind of like the layer to expose, oftentimes, some kind of pre-existing API that is more of the traditional kind of web endpoints, web services type architecture. But they don't have to, so an MCP server could just expose functionality in and of themselves without accessing some other API. Maybe you're an AI platform and you want to expose some kind of tools to consumer AIs, right? So it really depends on the application. Just a brief note on when you need an MCP and when you don't. And I have kind of two personas here in mind. I have an AI engineer who is building an application and a service provider who wants to expose some kind of functionality to the outside world, whether to sell it or to just distribute what they're selling. So, when do you need an MCP? As an AI engineer, you'll need one if you want to connect to an external service through some kind of pre-built standardized AI-friendly interface. And so MCP gives you that. You also want to do this if you want to connect your AI, your skills, the skill files that your AI uses, to external services in a compact way. So instead of like specifying some kind of tool or action as a curl command or a web API call, tools are just a lot more compact way of specifying what user intent maps over to what type of action that happens in the world. And then as a service provider, you want to expose your services to AI agents in some kind of standardized protocol. So this is kind of almost by definition what MCP is built for. When you don't need MCP, so for AI engineers, if you have like a self-contained AI system, you're using some kind of orchestrator to call LLMs, make tool calls that you fully control, just as functions. Say you're using TypeScript or Python, and you just want to write Python functions as tools, and your LLM is calling those. And there's not necessarily external service API calls, although you can have them in your functions. Then you don't really need MCP. And on top of that, if your AI has all the contexts and skills that are kind of easily downloadable into its own local set of resources, and it only accesses local files, directories, embedded databases, then MCP is really not that valuable. And as a service provider, maybe this is slightly contrived, but maybe you don't want to expose your services as, or you want to expose it as traditional APIs like REST endpoints and stuff like that. Or the functionality you provide can be delivered via context or skills that can just be downloaded locally. Then MCP is not really the right tool for the job. Okay, so for the rest of this time here, we're just gonna go through and build this recipe assistant MCP service that our Claude Code can use. So first things first, I'm going to go here and click on Open in GitHub Codespaces. So this will actually give me the environment that we're going to run on. Of course, you can do all this locally. I've run through this just on my local laptop, so that's also another option. But this is certainly the happy path. So I'm going to set up the workspace here. It's going to take a few seconds to just kind of set up. Okie doke. So as you can see, we're in the workshops repo. We're back here in the root README. I'm going to go ahead and click on the MCP recipe assistant link. So that'll just show me, we'll just get back to the README that we were just reading, but on the code space. I'm going to hit Command-Shift-V here for the pretty view. Just scroll back down here. So, okay, some prereqs here. We're going to use Python 3.11 plus. Hopefully you have a Spoonacular API key already at this point. If not, go ahead and start the setup. You're going to need a Union account. So again, you should see something like this in MCP Feb project. We're going to need UV installed. It's recommended here, but all the code below kind of uses it. So go ahead and just install UV, and maybe I'll, zoom in a bit and minimize this agent tab. Okay, hopefully that looks better. So UV should be installed now. And I'm going to go ahead and just create Python virtual environment. If you're not using UV, you should. It's really nice. I've not looked back. So I just activated the virtual environment, and now I'll install the requirements. Not sure why it's not. Oh, right. I need to cd into the tutorials MCP directory. Great. So now I can install the requirements. Look how fast that is. And then we're going to have to install this keyrings.alt package, just if you're in a Google Colab or GitHub Codespace environment. For reasons I'll kind of skip, but it's more around just like persisting your the way we're going to authenticate to Flyte. Okay. Next, we're going to install Claude Code. lot of setup here, but this gives you a sense of if you were to kind of like set this up from scratch, what the steps would be. And here, if you don't use Claude Code, I will do kind of a sidebar to use the agent tab here. I believe this is powered by GPT 5.2. I believe there's a way to set this up. I've tested it a little bit, but so if you don't have a Claude Code subscription or API key, you can maybe just set one up now or kind of just watch that step. So, give you a sense of this. So when you first run Claude, the Claude command, it's going to ask you how you want to interact with it or which LLM to interact with. So I'm going to go ahead and take this link and authorize this code space session. Oops. Not sure why that didn't work. Okay, trying to open this in the tab that I have an actual subscription for, and it's not working. All right, gonna try this again. Very, very strange. Okay, I'm gonna try this. All right, I'm just gonna quickly sign up on my email or my work email. Okay. Okay. Let's try this again. Great. All right. I think we're in business. Awesome. So you should see something like this in the terminal now. So I'm going to go ahead and trust the folder and just gonna give this a quick test. So that's Claude Code. If you haven't used it before, super helpful and implementing a bunch of different things, especially coding. But as you'll see later, you don't just do coding with it. Okay, so now that we have that part set up, we're gonna create an end file that has our Spoonacular API key. I'm gonna say code.env, and then I'm gonna real quick copy paste the API key in here. All right. So now I have this .env file here in my directory. And now we're pretty much set to serve our first MCP app. So what I'm going to do is I'll just start the server and then kind of walk back here and explain what all it exposes. So I'm going to say Python server.py. That's this file right here. I'll break this file down in a second. But for now, I'm just going to go ahead and run this command. And you can see that it's running a Unicorn server on this local port. I do not want to expose it to the public web. And what does this do? So if we look at the server file, it imports MCP. So this is the official Python SDK. It first, if you've used anything like FastAPI or Flask, it's very similar in terms of the programming model. But you first define a MCP object with some initial configuration. You give it a name, instructions on what this MCP is all about, what it exposes at a high level, and some other configuration that is useful for, for production purposes. So if folks are curious, I can break this down, but I'm just going to kind of skip this for now and just say this is useful configuration for when we deploy this to Flyte. This server uses this client that's under tools.recipes. So if we look here, tools and recipes, oops, not env. You can see a class defining this client using the API and just making the right, formatting the request in the right way to be able to access the various API endpoints that this Spoonacular API exposes. So it can search recipes, search for ingredients, search by nutrients, et cetera, et cetera. So go back to the server file. We have some helper functions here to get that client in the first place based on the API key. And then there are a bunch of tools exposed here. Yes. So at a high level, this MCP server exposes 6 tools. So it can search for recipes explicitly. So it can have a query with cuisine, diet. So these are all parameters that go into the API. You can search by ingredients. So instead of a query, give it a list of ingredients. Search by nutrients, which is pretty neat, et cetera, right? So once you have a recipe, this tool, get recipe info, gets you the full details of that recipe. You can search for similar recipes based on an recipe ID that you feed it. And there's also this autocomplete recipe. You can send it a query and it'll try to autocomplete a query for you based on that. So these are the tools, and you can really think of this as like web endpoints, right? But specialized for AI consumers. So if we go back to our README file, that's what this Python server.py is doing. It's defining this app and then running it as a local server with this mcp.run method. So if I open up my terminal again, you can see that it's running here still. I'm going to go ahead and split this terminal. And what I'm going to do is configure Claude code to connect to this MCP. So I'm going to copy paste this command, MCP add. I say what transport type the MCP server is using, HTTP in this case, and I name it Spoonacular MCP, and I give it the local endpoint. So now if I type in Claude MCP list, you can see that I have a Spoonacular MCP server, which is currently connected. You saw as I ran that this responded with the GET request and also POST request. So now I can ask Claude, can you give me a recipe for sourdough bread? And you can see it's now asking me if I, approve using this tool. So I say yes. Now it's doing a bunch of queries. So you can see, you can press Control O to kind of get more of the context here. The scrolling is a little weird. So these are the expanded contents of what the agent is doing. Do Control again, O again to minimize that. And now it's trying to autocomplete a recipe based on sourdough bread. See if it finds some results here. Cool. So it found a recipe, classic sourdough bread. Oh, so it actually didn't find a sourdough bread recipe here. And then it just used its internal knowledge. So that's actually, I've tested this before, and it's surprising that Spoonacular does not have a sourdough bread recipe. So I'll try another, where is that? Oh yeah, just copy these. I think these should work better. What can I make with chicken rice and broccoli? So it's gonna do another set of queries with ingredients. So it's found a recipe ID 635675. It's going to get the recipe info, boozy barbecue chicken. Interesting. Okay, so now here's the details of that recipe: servings, ingredients. I guess it's telling me what's missing from this recipe. So I guess, does this use broccoli? Oh no, yeah, it uses broccoli. So it kind of suggests other things. So what's happening here is that we have Claude code, which I believe is using Opus or Sonnet. I'm actually not sure which one. I'm sure we can find out. Sonnet 4.6. Based on the user intent, it's looking at the tools it has available to it. So I believe it has native tools available to it. But then it's determining that my query, excuse me, has to do with recipes, and so it finds the recipe MCP server that we have running over here, and then calls the tools in there. Sorry, I don't get to talk too much, so then my voice gets really dry very quickly. Okay, so in summary, we've created a local MCP server and connected our Claude Code client here to that server, and now Claude Code has these additional tools that it can use just for recipe search. So now what we're going to do is deploy the MCP server to production, because this code space is not going to be here forever. We need some compute to run this MCP server somewhere, right? So how are we going to do that? I'm going to kill this terminal. And in the next part of this workshop, we are going to do just that by deploying this same server to Flyte. And so the next thing I'm just going to do is do a little cleanup. I'm just going to remove the local Spoonacular MCP configuration. So if I do Claude MCP list, you should see that there's nothing configured for this project anymore. Okay. So next we're going to deploy this to the Union-hosted Flyte cluster. And so if you go to try v2.hosted.unionai.cloud, you should have access to this MCP Feb project. If you go to the app section, you'll see that I've been testing this on an existing app. And so the first thing we'll do is we'll export this Flyte project environment variable so we can kind of forget about it, but it should be MCP Feb. And then we're going to create a config file that points to try v2 hosted. So what this does is it just creates a local config file that has all the config we need to connect to that Flyte cluster. There's an optional step here to store the Spoonacular API key. I've already created it in that project, so you don't need to. So we'll all just kind of use the one that I've already created on the Flyte cluster. But if you want to, you can kind of rename this, and I'll kind of show you later where you would have to update this secret. So if you're to create a different key, like my Spoonacular API key, you'll have to change the app file over here, which I'll dive into this in a sec. But you'll have to update this to my Spoonacular API key. So right now it's only configured to use the one I already have. So back to the README. The next thing we're going to do is deploy the MCP server to Flyte. So I'm going to export another environment variable called app name. You can call yours anything. I'll make a new one called Niels test recipe MCP, or no, workshop. Oops. Niels workshop MCP recipe MCP. Then I'm going to say Python app.py. And I'm going to run this. We'll see a bunch of output. Then I'll unpack what's happening inside the app.py file. Just double checking this works. So I'm actually going to shut down my pre-existing one so I don't hog any compute. Once you would type this in, it'll ask you to authenticate via browser. So it's going to wait until I click on this link right here, the one on the same line. So I'm going to control or command click, open this up. And this just authenticates our current code spaces session so that it can actually submit deploy apps. So once you see this screen, we're going to hop back. And we see a bunch of stuff happened, right? So first of all, an image was built. More on that later. So actually, Flyte takes care of image building. So you can really easily productionize your apps. It bundled a bunch of code. So this is the code we saw earlier, the server, the recipe client, the app, which we're going to peek into in a second. And that's going to bundle it and send it off to object store. So in this case, S3. And so all our code is packaged up. And now, if I go to this link, you can see that the same logs, right? Similar logs, that there's a Uvicorn app running that's being exposed on this URL right here. So the way you can kind of do a quick check for this is if you go to the apps tab here, right here, and go to health check endpoint, you should see something that just says OK, and that just means that the app's running. To access the actual MCP endpoint that we saw locally, you can click on this link. And if you go to it on a browser, you'll see something like this. This is not, this endpoint is meant to be consumed with the text event stream type. So, but this just makes sure that the endpoint actually exists. I'm going to go ahead and copy this. I'm going to use it later. So this is your app. Flyte supports workflows, batch workflows, which are executed as runs, and also apps. And so these apps are longer-lived serverless applications that expose web endpoints, MCP endpoints, Streamlit dashboards, Grad.io apps, et cetera, Fast API apps. And so this is how we are exposing this kind of scale to zero service that we can hit through the web on a browser or curl commands or some kind of web client. I've configured this to have a minimum of 1 replica. One thing that's useful and something you should probably do right now is go to the app file and actually change this so that you're only using the resources when you need them, right? So this guarantees that there's always 1 replica up serving this app. But if you don't mind a little bit of a startup delay, you can set this to, say, 0 and 1. And let me disable this. And what this will do is if no one is using the app within some time period that you can also configure, then this will scale down to 0. So you're not wasting compute for this MCP server. But once any like AI agent or anything consumes any of the endpoints here, it's going to scale up to 1. So let's break down this app.py file that I've been talking about a lot. So what this is the configuration, the delivery mechanism that we're going to use to deploy this MCP server. So this MCP server, all it does is specify the MCP app, the tools it exposes, and really nothing else. So this is like the connection. If we go back to this graphic, this MCP server is just connecting to the Spoonacular Food API, right? But we need some way to ship that server to production somewhere. And that's where this app.py file comes in. So we import Flyte, and it exposes a really nice interface for defining images. So here's a flyte.image. We're going to use a Debian base image and add all the requirements files that we have specified for this project, right? So you can also manually specify pip packages like so, etc. Right? You can say FastAPI, Starlet, blah blah blah. But a convenient way is just to use requirements.txt. And then you feed the image into what we call an app environment. And so this is now the configuration to productionize the app. So you can think of server.py as kind of like the standalone thing you can just run locally and remotely for dev and production. App.py is the way you deliver it and ship it to production on Flyte. So it has a lot of different configs. I'm not going to go through all of them. The main ones to point out is this image one that tells Flyte what image it's going to use to host the app. The resources you want, right? So you can configure CPUs, memory, GPUs this way. Secrets. So we're going to use the Spoonacular API key that I already created on the server. The scaling parameter here. And that specifies, whether it scales to 0 or whether it has a minimum of 1 replica. And a few other things here, like the name and the port. Below is a Starlet app that is useful for things like controlling how to authenticate into this this app, the MCP server, right? So you can define custom endpoints here, like this /health endpoint, and you can mount the actual MCP section of that into a different root, right? So you can potentially have an MCP server composed of different MCP servers, right? And that's happening through Starlet, which is a web micro framework that's very popular. Then with this app environment, so this app environment, just to remind you, this is a Flyte construct, right? And so app.env.server is a function that tells Flyte, okay, how do I serve this thing? So what we're doing is we're defining the Starlet app, serving it with a Uvicorn server, and then deploying it like this with this if name equals main guard. Okay, so that's the app.py file. This is, again, your deployment mechanism to ship it to Flyte. And as you can see, this is already active. So I'll stop talking at you about this stuff, and I'll show you how to actually connect. So you have this new endpoint here. I'm going to grab the streamable MCP HTTP endpoint, and I'll hop back onto my terminal and go back to my README preview. And now I'm going to reconfigure my Claude code to connect to this. So transport HTTP, I'll call it the same thing. And then I'll copy in this app that I just deployed. Make sure it has the /poonacular/MCP. So now, if I do Claude MCP list, you can see that I'm connected to this service. And just as a quick check, what I can ask, what can I do with stale bread? So it's going to search by ingredients first. So it's finding a few recipes: panzanella, bread salad, French toast. It's a good idea. So it's asking me, which one would you like me to fetch? So this is working, right? So now we're interacting, and we can see the logs here too of this Claude Code client here interacting with this remote server sitting on the Flyte cluster. Okay, but there's still one problem, which is this is accessible. I mean, let me try this out. So I'm going to go to the health endpoint on a, yeah. So I just went to a incognito tab, which shouldn't, have my authentication cookies on the browser. And you can see that this is still accessible. So MCP, when MCP first rolled out, security was a big concern. There weren't really servers and clients out there, frameworks out there that really well supported it. But now, a year or two later, things are much more well supported. And so what we're going to do next is we're going to secure our MCP server. And so I've done that for you already. You might have noticed this requires auth environment variable here in the app.py file, right? So I set it here as false by default, but with the app environment, it's actually true by default. I just wanted to kind of tell this progressive story here. So if we set this value to true, so I'm going to say requires auth equals true, Python app. So we're going to redeploy our app, but with the requires auth equals true. You can see that we've served our app now. I believe it's restarted, so it's pretty fast. You're just shipping code, so you're not rebuilding images and all that stuff. And I'm gonna say Claude MCP list. Still connected. Now we're gonna create an API key. So I'm gonna reset this. Claude remove. Yep. And now we're gonna make sure we can authenticate using the Flyte API key, right? So actually, just a quick test. I'm gonna reconfigure that again, and then Claude MCP list. Okay, so this is the curse of the demo. This was working before, but I think I changed a few things where it actually is not doing authentication here. So I need to add some additional configuration to lock down this MCP server. So I will definitely follow up with that. So it's slightly embarrassing, but we're going to go ahead and create an API key to authenticate with Flyte. So the way we're going to do this is we're going to say Flyte create API key, give it a name, Niels API key. So I'm actually going to go ahead and delete this since this is now all, the secret is now on the web, the live stream. So I'm going to just delete this immediately. But that's how you do this. So this should be your way that you can programmatically access Flyte, the Flyte cluster. And so we're going to use this secret later. So go ahead and save that somewhere safe. I already have one before this, so I'm going to go ahead and delete API key. Cool. And so now the way I'm going to go ahead and actually just redeploy this just in case. And now I'm going to redeploy or reconfigure Claude with that API key. Actually, I'm just going to create this temporary API key again, and then delete it after I'm kind of done with this workshop. Okay. Oh yeah, this might be annoying to copy paste. Yeah, there's this. We need to fix this. Okay, so just make sure you don't have like the CLI output stuff in the middle. So hopefully this should work. Oops. And then I'm gonna reconfigure my Claude MCP to use this. Just gonna punch in the header here already. Then I'm missing the app URL. So the app URL, find over here. Okay, and I forgot to remove it. Okay, and we run this command. Great. So now we have a secure connection to Claude MCP. So now it's connected. So we can ask it, what's one more thing? Give me a spaghetti. Is that how you spell spaghetti? Recipe. Hopefully it'll correct me. All right, so you see that Claude is making tool calls to the MCP server. And yeah, so that's pretty much it. The way this works, you can sort of compose MCP servers together, but the way you do that is through the AI agent, right? So you don't have like nested MCP tools that kind of depend on each other. But I found that generally you treat these tools as like these little self-contained things that you can compose together through, skills files. And so the skills files really are the way you can have the agent understand, okay, here's my workflow for getting recipes. If, based on some ingredients, I get recipe IDs, I get the recipe info, and then based on that, I can search for similar recipes, so on and so forth, right? So yeah, that's pretty much it. The last thing I'm going to do, before I forget, is delete the keys that I just made. Delete. Yes. And yeah, we're pretty much at the end of the workshop. I'll probably spend a few minutes just like getting this app.py configured to actually require the auth, right? So by default, it's false. I think I need to add a little bit more code here to get it to actually pass through the authentication so that it blocks people that don't have the Flyte API key. But yeah, if anyone has any questions, Yeah, feel free to type it in the chat. I'm also on LinkedIn. You can find me over here under Bantilan. Feel free to connect. Happy to answer any questions you may have. And yeah, thank you, everyone. I think, so one thing that would make this tutorial even cooler is if you did actually connect it to a weather API. And so you can have the agent look up the weather. And if your query is something like, you can ask it, give me a recipe that's appropriate for dinner tonight. And so then the agent can look up the weather API for your location, look at the forecast for the evening. And if it's cold, it may, suggest soup or something like that. So that's, just giving ideas on how you delegate the composition of different tools to the agent itself, and giving it skills through the skills files or the context to give it hints on what kind of workflows you want it to do, what kind of tools and in what sequence you want them to be called. And then, that's the amazing thing about these types of models now is that they're actually really good at determining and planning which tools you need to call. So that's it. What did we learn? So going back to the learning objectives, what we did was we kind of broke down how MCPs worked, what place they have now in the AI ecosystem. Just to sum that up really quickly, MCPs are really useful for AI builders. Either if they want to use pre-built MCPs that the service provider has created already. So it's really nice to be able to just log into a SaaS platform, get the MCP connection credentials, and then just use it on your local system or in your own AI systems internally in your product. So that's one strong use case. Another is if you do just want to follow the protocols, right? So even if there is not a pre-existing MCP server for an external service you want to use, MCP at this point is kind of just the standard to connect with them. But of course, if you want, you can just have the agent give the agent a skills file for like the web endpoints, right? So you could just use like a standard like traditional REST endpoint web service for exposing your AI to external services. We built an MCP server locally. So you saw how we did it locally. We connected Claude to it. We deployed the server on Union-hosted Flyte. You saw how that all worked, and how to actually connect it and make it secure, so that your local cursor IDE or local Claude IDE can access it through API keys. And that's pretty much it. Thank you, everyone. I'll hang around here and debug this thing and answer questions as they come in. So actually, I think, so this, I'm hopping onto my local here. I think what I'm missing here in this app file, I actually deleted it, but I did actually need it. Yeah, so this was a change I was messing around with. So right. So what this is doing actually is I'm using pass-through authentication that will then use this middleware on every request to make sure that the auth credentials are correct. So that's my hypothesis. Let's test it. I'm going to run this again here, just locally. So I have wires. Actually, first I'll do app name. And I forget my app name. What was it again? think it was Niels' workshop, recipe MCP, boom. And then let's say requires auth equals true. And then Python. So this is going to redeploy my app. Yeah, is anyone deploying MCP servers these days? I'm curious. I'm actually building one internally that we're going to eventually make external. That is a kind of a Union MCP. So that will give agents access to run stuff and deploy stuff on Union. So it's pretty cool. Okay, so the app is served. Now I'm gonna configure it with my local CLOD. So let's see, on CP list. Okay, so I have no servers currently configured. Now I'm gonna do this. I will hide it from everyone since I'm using my persistent secret. Or actually, no, I'm jumping ahead here. So yeah, I actually want to add this without the authentication. So because I want to test whether that actually works. So let me go ahead and just add this by itself. Right. I'm going to call MCP list. It's a good sign. It's trying to connect. It's going to time out at some point. Oh, I think it's still redeploying. I see that my app is still pending. Yeah, this is the issue when you scale down from 0. You have to kind of wait for the compute to come up. So what I'll do is actually I'll redeploy this app with 1 to 2 replicas. I'm going to deactivate this. Okay, so our app is starting up. Okay, cool. And then CP list. Okay, so that change didn't actually work. There's some more debugging to be done here. Okay, awesome. Well, if there are no other questions, I'm going to hop off. Thank you, everyone who attended. Again, connect with me on LinkedIn. Feel free to ask any follow-up questions about this, and I'll see you later.